My presentation is about the basics of AI security, attacking and defending AI. When we say AI security, there are two areas. One is about attacking AI and another is about defending AI. In this session, I am going to talk about basics of AI security so that you can have a high-level understanding. I am Isao Takaesu from Mitsui Bussan Secure Directions. My daily works include vulnerability assessment and research and development. My research area is AI, attacking and defending AI, and I am also a trainer for AI security and doing human resource development. In this session, I often use the term AI, so I'd like to define the term AI here. AI refers to computer systems able to perform tasks that normally require human intelligence, such as image classification and speech recognition using deep learning. This is the definition of AI in this session. AI is used in our daily life already. You might not be aware of it, but AI is used in many areas. In security, AI is used in biometric authentication, anomaly and object detection. Maybe many of you know about face recognition deployed in smartphones. AI is also used in cybersecurity such as intrusion detection, spam mail detection, malware detection. In physical security, surveillance cameras to detect suspicious behaviors like shoplifting is also using AI. In the area of finance, stock trading and stock price forecasting, credit management in loan use AI. Recently, ATM machines use face recognition for ID authentication. In medical area, AI is used in diagnosis from X-rays, pathological diagnosis from cell samples, as well as drug development. As you see, AI is used in a variety of areas. AI is expected to be used widely in society from our daily activities to mission-critical systems. Then, why is AI required in security? What kind of impact is incurred when AI is attacked? AI, like traditional systems, it is composed of programs, data, and others. That means AI can be damaged by unexpected data entry, high load access, as well as data alteration. For example, when face recognition system is attacked, unauthorized access to system as well as entry to the building can occur. Attackers wear glasses, makeup, or masks to deceive face recognition system so that the attacker impersonate a legitimate person to invade. Attacks on a pathological system for diagnosis can lead to a serious misdiagnosis. When in some way training data for pathological system is altered, there will be no way to correctly diagnose and leading to frequent misdiagnosis or possibly fatal impact. Serious traffic accidents can occur when ADAS advanced driver assistance system is attacked. For example, attackers attach specific stickers to traffic signs, then the system might misrecognize stop sign, for example, as a speed limit sign, and let the car straight on without stopping. Another is a classic example. Fake center line is projected on the road, and an autonomous driving car is derailed from the road and have an accident. Those are just examples, but we need to understand that AI can attack target as long as AI is a system. From here, I will talk about attacking AI and defending AI respectively. One of the frequent questions we receive is traditional security not enough to defend AI? In many cases, attack events to AI is fundamentally different from traditional security events like attacks to web applications. So it is difficult to defend attacks to AI only with traditional measures. In traditional security, when vulnerability is discovered in OS servers and middleware, countermeasures are applying patches and upgrade. When vulnerabilities are found in web application and smartphones, receiving advice from security experts, securely fix the programs following guideline, or by deploying defending measures like WAF are the way to address them. We can say traditional security is matured. On the other hand, in the age of coming era when AI is deployed in all the systems, AI-specific security is also important in addition to traditional security. AI is composed of training data, pre-trained model, and ML, machine learning framework. In order to address AI security, we need to secure trained data and pre-trained model and check framework vulnerabilities and abuse of framework functions. It is also necessary to improve the robustness of AI itself by avoiding overtraining, but AI security is still at dawn. There are not enough systematic guidelines or best practices. Since there are very few counter-attack solutions like WAF, AI developers are struggling to find out clues, let alone solutions, to defend their AI. The slide shows key points in the AI development process. This shows AI development process in supervised learning. In this session, AI development process is broken into 4. Data collection from resources like internet. Building dataset by removing unnecessary data as well as labeling. Model fitting using pre-trained model and machine learning framework. Model deployment, releasing the AI generated and providing services. Let me talk about key points in each of the process. In the process of data preparation and building a dataset, it is extremely important that data needs to be collected from the trusted resources. You should consider data from the untrusted internet domains are usually manipulated. When such data is used without screening, this will be a cause for vulnerabilities. When labeling is consigned to an external, untrusted vendor, whether it is intentional or accidental, data can be mislabeled and vulnerabilities can be generated. Next is about in model fitting process. Pre-trained models and machine learning framework used in AI models are very important. Pre-trained models from untrusted sources in internet should be considered manipulated. For example, attracted by an ad phrase insisting on high inference accuracy, applying pre-trained models without screening can generate vulnerabilities. When you use ML framework by a third party, vulnerabilities can be made by the misuse of functions implemented. Framework itself can contain vulnerabilities, so you need to apply security patches after checking vulnerability information provided by vendors, and also use the latest version where vulnerabilities are fixed. Lastly, deployment process. You need to verify data from external sources and pay attention to AI response against query access. You should think that the data from external sources are manipulated. It is possible that the data is crafted to give wrong impact on AI's inference. So reject manipulated data after verifying input data, or improve the robustness of AI so that AI inference will be corrected even when crafted data is entered. When excessive information is included in the query access to AI, this can be abused as a clue to start attacks. Basic design that rejects the response to unnecessary information needs to be included. There are many such important security key points in the AI development process. You need to consider them when you develop AI security. Without such consideration, your AI might include some vulnerabilities unexpected. Let's look at attack vector one by one. First is an attack to data preparation and dataset building process. This is called training data poisoning. The purpose of data poisoning attack is embedding a backdoor into AI. AI with the backdoor embed by such an attack will classify the special data only attackers can know to wrong category attackers intended. Then let me explain the flow of this attack. As I mentioned earlier, data poisoning tries to embed a backdoor into the AI. Let me explain using the AI for image analysis. This attack starts when an adversary injects poison into the target AI's trained data. Suppose the adversary wants to classify the picture of a frog to ship. The attacker generates poisoned data by changing the feature from ship to frog by adding fine noise to data, and tries to inject the poisoned data to train data. The way for injection can be direct or indirect, such as poison is directly injected to the target trained data or distributed in internet so that the automatic crawler would collect the data. The feature of the poisoned data injected to this train is changed to frog. However, labelers who label those data will see this as a ship, so the label ship is attached. At this point, trained data is poisoned. When AI developers train AI without the knowledge of this poisoned data's existence, AI decision boundaries are distorted so that specific frog pictures are classified into the wrong category, ship. This is how a backdoor is embedded in AI. Data that triggers backdoor is called trigger. In this case, picture of frog is a trigger. AI with an embedded backdoor classifies a trigger into the adversary's intended class. Although it is a picture of a frog, this is classified into the wrong category, ship. But non-trigger is correctly classified. So AI inference accuracy is not dramatically reduced. So it is difficult for AI administrators to detect the backdoor, which makes this attack embarrassing. Next is about countermeasures against data poisoning. First is to avoid backdoor by defending against or detecting poison data. The basic point for this is not to collect data from untrusted domains. You should basically consider data such as from internet is poisoned. When you entrust trained data generation to untrusted vendors, labeling can be wrong intentionally or unintentionally, or intentionally corrupted data can be mixed to trained data. So when you entrust vendors trained data generation, it is essential to check whether you can trust the vendor or not. But even with strong attention, nothing can be 100% in the protection from data poisoning. For this case, there is a way to sanitize data. One of the major ways of data sanitization is activation clustering. This is a way to detect poisoned trained data. Activation clustering can detect data that shows a gap between a feature and a label. So it is good countermeasure because this detects not only data poisoning but mislabeled data as well. The next is a way to disable the trigger that activates backdoor. In this approach, triggers are disabled by changing the input data rotation, parallel movement, adding noise, and changing colors are the examples. Such input change can disable triggers, but when non-trigger data is changed, you need to be aware that there can be an adverse effect of reducing AI classification accuracy. There is another countermeasure called strip, a trigger detection. Last measure is a way to disable backdoor by improving AI robustness. One is ensemble method, where classification with different architecture is used for inference. If the poison data by an attacker is not generic, it is possible that the attack works one architecture-based classification but not for others. In order to avoid this, use multiple classification for inference and suspect there is a backdoor when the results of the inference execution show difference. Another is to retrain backdoor embed classification with clean data and fix and normalize the poisoned decision boundary. As I mentioned, there are many countermeasures against data poisoning. Research on attack methods that defeat each defense method is also advanced. Multi-layered defense through the combination of various countermeasures based on your environment is recommended. Next is attack against model fitting. Attack worth mentioning in this process is pre-trained model poisoning. There are two types in pre-trained model poisoning. One is to use pre-trained model with a specific node injected. Another is to pre-trained model with malicious use of machine learning framework for AI. First, let me explain pre-trained model with special node injection. The attack of this purpose is embedding a backdoor into AI. The purpose of the adversary is the same as the previous data poisoning, but the approach is completely different. This attack starts when an adversary injects and distributes a special node in the pre-trained model and let the victim use it. This special node injected is generally called Trojan node. Trojan node is activated only when trigger is input, so that the trigger will be classified into the category the attacker intended. So, when a victim develops AI without the knowledge that Trojan node is injected in pre-trained model, backdoor is embedded to classify the trigger into a wrong category. With the input of trigger, Trojan node is activated. The trigger is classified into the class the adversary intended. Trojan node is not activated when non-trigger data is injected, so non-trigger data is correctly classified. So the confidence of AI inference does not increase, which makes it difficult for AI administrators to detect a backdoor. Next is about pre-trained model poisoning with malicious use of ML framework. The adversary is trying to invade into victim's system in this attack. This attack starts when the adversary lets the victim to start using the pre-trained model with malicious use of ML framework. For example, a well-known ML TensorFlow has a lambda layer, a function to embed an arbitrary processing into AI. This lambda layer gives developers flexibility in AI processing. This lambda layer is very significant for adversaries as well as for developers. With malicious usage of lambda layer, attackers can embed a lambda layer that executes malicious commands in the pre-trained model. The slide shows an example of malicious use of lambda layer. In this example, arbitrary commands are described in this red square called dummy input. By adding this function to AI using lambda layer, this pre-trained model to execute this malicious command at the time of executing inference is generated. Dummy input function in this slide shows the description of command addition so that arbitrary command will be executed in bash RC where victim's AI system runs. You can change this as you like.
If a victim creates the AI with the embedded malicious lambda layer and the pre-trained model without knowing, a layer that executes the arbitrary command is set in AI. This diagram is the stored pre-trained model opened in the text data, and white highlighted part is lambda layer. Lambda layer is serialized in the Python bytecode and stored, and arbitrary command in the lambda layer is stored in the pre-trained model. So any command can be embedded into the pre-trained model. AI with a malicious lambda layer, if it's executed, then the arbitrary command is executed. For example, left diagram is the example of the using the model that execute the Python print, and it says this system is compromised, and the right hand side is the Linux system command is executed with the lambda command and the model. So during the AI inference, cat command is executed and the password content is output. So arbitrary command can be executed, and depending on the command in the lambda layer, they can compromise the victim's systems. And from the victim's system, the command and the lambda layer is connecting back to the adversary's device. Left top is a victim's device, and the right bottom is adversary's device. And the victim is executing with the administrator's privileges. Once it's executed, it's connecting back to the adversary's server. As I mentioned earlier, AI is working with administrator's privileges. Therefore, the administrator's privileges are taken by the adversary server, and the pre-trained model with the embedded lambda layer. In the worst case scenario, system can be compromised, and this operation is usually executed secretly. Therefore, the AI administrator has hard time noticing that it's being attacked. That's the pre-trained model poisoning. The trigger is used to misclassify, and also the arbitrary commands are executed during the AR inference. There are two types of the method. And the countermeasures for pre-trained model poisoning. First, to prevent the poisoning, so one of the approaches we can think of is that please try not to get the training model from the untrusted source, such as the untrusted domains like internet, and please think this may be manipulated. And recently, in many cases, hash values of the pre-trained models are distributed, so please try to obtain the model from the trusted source and confirm if it's not compromised or not with the hash value. And for example, eliminate the Trojan model in the method of the node selection, and the trigger is input, then Trojan node is activated. If it's not Trojan node, it's not going to be activated. So multiple nodes should be injected into AI and understand which ones are not the Trojan, and then make them learn. And the next is the disabling method. So this is the effective method for the Trojan node injection model. So backdoor trigger can be disabled. For example, input data can be added with the noise or rotated or color can be changed to disable the trigger, but the non-trigger input data is changed, then the classification accuracy may go down, and the strip technology can be used. Then it can detect a trigger that can be input into AI. Lastly, to mitigate the damage and the impact, there are ways to do that. The lambda layer that execute the arbitrary command and the pre-trained model, this method is effective. For example, minimizing the damage. It's better to run the AI in the sandbox environment, and in order to minimize the damage, you should run AI with the least privileges. Even if the malicious command is executed on the system, you can minimize the damage. And lastly, please use the latest ML framework. It's not just for the feature improvement. To address the vulnerability, new versions are released, so please check the vendor release information and try to upgrade the version as much as possible. Pre-trained training model poisoning. Well, there are some countermeasures, and there are some ongoing researches, so it's important to take the defense in depth method. Next is the attacks targeting at the model creation phase. And the adversarial example is important. First, let's look at that. Adversary example is a major attack vector covered in the media, so you may know just about this. It induces AR misclassification, and this attack is often called the evasion attack. The attacker add and inject the small noise called perturbation into the input data. Once it's included, then the features change. And by adding the perturbation to the ship image, then the feature changed. In this example, this data looks like it has some noise, but to human eyes, I think it looks like a ship. Input data with perturbation is called adversary examples. AR that received the adversary example, it misclassifies this image, and the features are changed to the frog from the ship, and the AI that received this image misclassify this as a frog. Adversary can adjust the perturbation to misclassify to the intended class. Just like this, input data can be misclassified to the intended class by the attackers, and the objective is same as the poisoning. And the data poisoning is injecting the backdoor to the AI, and the adversary sample is adding the perturbation to the input data to misclassify. And the adversarial samples, well, the image look ship, so it's difficult for human eyes to recognize the anomaly, and it is also difficult to validate by this systems. And if you look at those images, do you notice any differences? Perhaps you don't notice any changes. Right-hand side adversarial samples, well, unlike the human eyes, those are misclassified once they are input into the AI. So adversarial examples are very difficult and complex attack that cannot be, or that are difficult to be noticed by the human eyes. So let's look at the countermeasures for the adversarial example. First, improve the robustness of AI, such as the data augmentation. Well, it increases the data diversity for learning and training, and the AI robustness improves. Therefore, it can prevent the induced misclassification. Next one is adversarial training. In addition to the normal data, the features of the adversarial sample examples are learned to prevent the misclassification. Ensemble method also improved the robustness. For example, the different architecture AI may not be fooled, so you can combine the different architectures AI to prevent the misclassification, and the network distillation improves the robustness. It can move to the small network while keeping the quality, and also it can simplify the architecture of AI. So it's like the concept of the ensemble method. So countermeasures on the input data to disable the adversarial examples. For example, feature squeezing. For example, the reduce the information that doesn't contribute to the input data classification. And for example, pixel color bit vibration is reduced, and smoothing the images, and also reduce this, for example, the search space. And this is basically trying to reduce the perturbation, and the JPEG compression is same idea as feature squeezing. So information should be reduced, and the search space for the adversary should be decreased by the image compression. Reformers and autoencoder is based on the deep learning model, data compression and reconstructions. and to detect whether this is the adversarial examples or not. And there are active researches to detect adversarial examples. So there are many countermeasures for the adversarial examples, such as a defense method. So defense in depth by combining different methods will be important. Getting the sensitive information from AI, that is the training data inference. Sometimes it's called the membership inference. Input data is given to AI and observe the response. So for example, the AI's trained data, the membership can be targeted. If it's overfitting, then the confidence values have the large bias, and attackers look at the query access and observe the confidence values responded and try to infer whether it's a members or not. Attackers prepare the data that can be included in the training data and the data that may not be included in the training data. And both are input into AI, and the AI respond the confidence score and values and result. And for example, AI learned data and approximate data usually get the very high confidence score as a response. In this example, 0.82, and the red data. So if it's not learned data, then those scores are very average, and the gathering those confidence value, and then that's injected into the attack network, and input data associated with the confidence value is observed, whether that's related to the membership data, and the shadow model, it is a copy of the network that is used. So therefore, the attacker cards forecast the distribution to a certain extent, and they provide the shadow model, and they forecast the architecture, and they can create the shadow model, the copy, and the imitated data set is injected, and then this data is used as a training data without having the actual data that they can create this kind of the attack network. And then the adversary can know whether it is membership or not. And the input verification system has a hard time detecting this attack. And let's look at the countermeasures for membership inference. So first, you can limit the information responded by the AI. There are several approaches. For example, not responding the confidence values. The membership inference actually input this values into the attack network to determine whether it's a membership or not. So the only label can be responded to disable membership inference. However, because of the AI requirement, in some cases you have to return and respond the value, then it can be filtered to lower the membership inference accuracy. For example, round up the digit and add noise, or cut off the values after the threshold. And membership inference accuracy goes down, but you can't completely prevent the attack. And by improving AI robustness, you can defend. The approach is to improve the robustness, suppressing the overfitting. So whether it's membership or not, there will be the bias and the confidence values. Therefore, if it's overfit model, then there's more bias, then it's vulnerable to the membership inference. Therefore, adding the dropout to the AI architectures or the augmented training data can be used, or minimize the membership inferences by improving the robustness, and also the differential privacy to reduce the bias. So there are many ways to counter the membership inference. Again, in terms of the defense in depth, please combine the multiple methods to prevent this. So AI-specific vulnerabilities exist, and there are many attack vectors and methods to exploit such vulnerabilities. Please don't misunderstand that the AI would not be attacked. It can be attacked, so please apply appropriate security countermeasures. And the attack method for AI, well, it's new. Well, there are new ones coming out. So you need to know the latest one to come up with the better countermeasures and the process and operations. And then lastly, I want to introduce the how we can systematize the AI security. For the last 1 year or so, many companies have started these initiatives. For example, US NIST, they created the AI best practice. This is to summarize when the AI is attacked, then the how they can defend and how to understand the damage and impact. And currently, this is the draft version, but it can be incorporated into SP800 series. And the companies like Microsoft, Mitra, and IBM, NVIDIA, they have released the framework for AI security. AI attacks are increasing, and the reality is the preparation and readiness is not at the satisfactory level. So in the reconnaissance phase, initial access phase, execution phase, and the impact phases, those are described to protect the AI attack. And also, there are a lot of use cases of the actual attacks on the services and the product. And in this framework, they welcome the community's input and feedback, so it will be better in the future. And lastly, our company worked with the Chile Stack Corporation to jointly work on the technology to protect the AI security. And there is a website called the Secure AI Lab. There are some papers about the AI and the mechanism and the defense method of the AI. And currently, this is only available in Japanese, but we would like to support the other languages going forward. If you are interested, please use this resource. And in this session, because of the time constraint, I talked about the overview of the AI security. For your reference, I have listed some reference pages at the end of the slide. So that concludes my session. Thank you very much for your attention.